So as we see on a lane drop CB here, we observe that at this second lane drop C, there is the resultant inward force on B. Kwa nini tunasema kuna resultant force on B? This is because, my dear student, here the lane drops here, the drops here is dissolved a half, yani a half ndio ime dissolve kwenye liquid kama tunavyojaribu ku observe. Kwa hakuna upward force ambazo zita act, lakini hizi force ambazo zina act pembeni hapa zita cancel kwa sababu zina act in opposite direction. Lakini hizi za chini hizi hazitaweza ku cancel kwa sababu hakuna balance of the forces hapa juu. Kwa hii ita indicate kuwa there is there is the resultant inward force on point B. Now on C here, the same with that on B, my lovely student. We have the force that act downward here, the resultant force, which is represented by the symbol F as we see here. Now we should see the explanation related with what we see there. So the average distance apart of the molecule is such that attractive force balance the repulsive force. Kwa sasa ile average distance ambayo inaokaa apart of the molecule, ile is such that attractive force balance the repulsive force. Kwa those attractive force must balance the repulsive force as we see on our diagram here, kwamba ile attractive force, zile force of attraction zinakuwa zina balance ile repulsive force. Repulsive force ni force ambayo ina act away from each other, zile force ambazo zinavuta kuelekea yani force ambazo zinakuwa force ambazo zina act away from each other, lakini attractive force ni force ambazo zina act toward each other. Kwa sasa hapa kuna balance of those forces as we have been told according with our statement here. So the average intermolecular force between A and also the surrounding molecule is 0. Kwa hii this average intermolecular force between A and that intermolecule must be equals to 0. Kwa ukiobserve hapa kwamba hizi force ambazo intermolecular force ambazo zinaokaa kwenye hii body A zitakuwa ni sawasawa na sifuri kwa sababu ya ile attractive force imeibalance ile repulsive force. There are some concepts here you could be asked, my dear student, that imagine we have the lane, we have the drops, and that drops act, that drops is dissolved into the liquid. Why why we say that there is no any inward intermolecular forces? Utaulizwa hivyo, kwa nini hakuna inward force ambayo ita act hapo? Utamwambia kwamba reason ni kuwa kwa sababu zile force ambayo, kwa sababu ya ile balance of attractive force pamoja na ile repulsive force. Now consider now a molecule such as a COB. Let us go and see and consider that a molecule C and also that B on the surface of the liquid as it is shown on our figure number 6.1. So there are very few molecules on the vapor side above this C or B. There is no any few molecule, hakuna molecule ambao wata exert kwenye vapor side kwenda juu, watakao ambao wameact kwenda juu kama tulivyoona kwenye zile diagram. So if C is displaced very slightly upward, a resultant attractive force on it due to the larger number of molecules is below 8. Kwa hapa tukitokea huyu C is displaced very slightly upward, kwa ukidisplace kwenda juu, basi tutaona ile resultant attractive force ambayo ni F on it due to the larger number of molecules belong to it. So as we see here, consider the two atom or molecule. Let us look for the two atom or molecule exerting a force of the attraction on each other as it shown on our figure number 6.2. Now on your figure 6 number 6.2 here, we are going to see the two atoms or molecule exerting a force of attraction on each. Kwa tunaenda kuangalia sasa kwamba kwenye figure ya 6.2 here, we are going to see a two atom or molecule. Those are exerting a forces of attraction on each other as it shown on our figure 6.2. Now, if the force F on A moves the molecule a small distance A of to the right, then the work this one on A is given by this one. This we are going to see how can we determine the work. How can we obtain the work, my lovely student, by considering the force that act on A and moves the molecule of the small distance. Tutaenda kuangalia sana, but we know that we get this work done, au sometimes tunaita ni energy, kwa kuchukua ile force times the small the change of the distance. Kwamba tunapokuwa na molecule mbili, lakini zile molecule mbili kuna mvutano fulani ambao unaapia. How can we get the work done? Anakuambia kwamba we get the work done by taking that attractive force or repulsive force ambayo ita exert pale katikati, tutazidisha na ile distance ambayo ita occur between those two atoms. So as we observe here, my lovely student, we have this atom A, and also we have the second atom A as we seen here, my dear student. But on this here, on this figure, represent the forces of attraction between molecule. Kwa hiyo hapa ina represent ile force of attraction between the molecule as we observe here, my lovely students. Now, on this atom A and also atom A, between these two atoms which are the same, there is the force of attraction that occur. This attract each other. Kwa hiyo tunaona kasa kwamba attraction force ambayo ina exert hapa kwamba huyu wa kwanza the left side mwanzoni alikuwa hapa, lakini sasa akavutika, mwisho wa siku akasqueeze some small change of the distance as we see. The distance between A and A here, atom A and atom A is represented by R. But the increase of that the small distance here is called the change of R. Now we observe that from the body where this was started at the attraction, now their distance must be a change of R, then we add it by R as we seen here. Now let this U here result to change in the potential energy. Kwa huu change wa U amaanishe kwamba ni change of the potential energy as we seen here. Now we could say that we know the change of the potential energy must be equal to the negative of the work, the change of the work done as we observe, my lovely students. Now this will be our equation number 2 for our sixth topic here. So the negative sign indicate that the negative sign must indicate that force is attractive and the potential energy at increase. Kwa hiyo negative sign anakuwa ana indicate kwamba huyu force ni attractive na pia potential energy anakuwa anapungua. Kwa this is the meaning of the negative sign as it is shown here, my dear students. Now we should conclude by saying that therefore the change of the potential energy must be equal to the negative change of the work done, which is equals to force times the change of the distance. Now we get the change of the internal energy kwa kuchukua ile negative force times the change of the radius as it is shown here. Thus in the limit here we could differentiate the force. In the limit we are supposed that for the small change, let us make this F the subject, and we should obtain that the force must be equal to negative derivative of the potential energy. Then we divide it by the small change of the distance as it is shown here, my dear students. So by saying that this will be the end of our session here. Now I would like to invite you again for another session I wish you all the best. Have a nice moment.